This is NSAA 2021, Section 1, Question 44. So this question gives us a section of the periodic table with some of the elements listed, and we've got a list of trends and we have to work out which of the trends stated is correct. Our first trend is that of group 1 boiling points. So does potassium have the highest, followed by sodium, followed by lithium? Well, let's first think about what actually are boiling points. Boiling points are the strength of the bonds between the atoms. So if they have a stronger bond, it's needs more energy to break them apart. And what causes those bonds to be formed? What indicates the strength of those bonds? Well, it's the bonds between the outer electron of one atom and the nucleus of another. So say these are our two atoms. The bonds would be this negative charge attracted to this positive charge. So what do those look like for our group 1 metals? Well, they look something like this. So lithium is our smallest atom, so it's going to have a quite short bond, then followed by sodium, and then our largest one will be between potassium atoms because they have the most shells and therefore are the biggest atoms. So which of these has the strongest bond? Well, because these are so far apart, they're going to be a lot weaker. There's going to be less attraction between the nucleus and the electrons. So in fact, potassium is going to have the lowest boiling point. So in actual fact, our trend should go lithium, sodium, potassium. So this is not correct. Our second trend is the electrical conductivity. Is sodium chloride in liquid form the most conductive, then followed by sodium chloride in a solid, and then sodium solid? Well, what do we know about the general conductivity of sodium and sodium salts? Well, it's made up of ions, first of all, and those ions can only be conductive if they're in a solution, so if they're liquid or if they're in an aqueous solution. So our two solids here, our sodium chloride and our just sodium solid, would not be able to conduct. So this would have the most electrical conductivity, but these two would have the same solubility and same conductivity. So this is not correct. Our third trend is the reactivity. Does bromine have the most reactivity, followed by chlorine and then fluorine? Well, let's think about how these actually react. If we draw out these atoms, we know that they have 7 electrons in their outer shell. So they have to react by accepting 1 electron into the outer shell. So which is that most favourable for? Well, this one has the fewest shells and therefore has less shielding on the positive charge of the nucleus. So it has stronger pulls on incoming electrons and therefore is more reactive. So our reactivity series for this would actually start with the lowest being bromine going up to the highest being fluorine. So this should actually be flipped around, so it's not correct. Our fourth trend is the melting points. The silicon oxide have the highest, followed by water, followed by sodium oxide. Well, for this one, again we have a melting point, so similar to our boiling point, this is going to rely on the strength of the bonds between these molecules. So let's draw these structures out and see what sort of bonds they have and what are their relative strengths. So if we start with silicon oxide, that forms these structures where each silicon is bonded to 2 oxygen and vice versa, and it forms these big, huge structures. And these are all covalent bonds. So these are large covalent structures. Next, if we look at water, we should know that water can hydrogen bond with other water molecules, so it forms a big hydrogen bonded network. And then for our sodium oxide, these are all ions, so each ion is bonded to other ions and forms a large ionic lattice. So we have covalent bonds, hydrogen bonds, and ionic bonds. But which ones are the strongest? Well, covalent bonds are definitely the strongest. These share electrons between each other, so they're a very tight, strong bond there. That's going to be followed by ionic lattices, as these interactions between charges are much stronger than the interaction with hydrogen and just lone pairs. So the actual order of melting points should be our silicon oxide, and then our sodium oxide, followed by our water. So this is not correct. So that leaves us with our final trend, which we know must be correct, but let's see why. So this is the number of double bonds per molecule, with carbon dioxide having the most, then oxygen, and then water. Well, let's just draw out all of these structures and count the number of bonds. So our carbon dioxide looks like this. We have 2 double bonds with our carbon bonding to each oxygen. Our dioxygen molecule has one double bond between the oxygen atoms, and then our H2O looks like this. We have no hydrogen bonds there. So yes, this is the correct order. CO2 has the most, then oxygen, then water. Give that a tick. So our overall answer is E.